Rich, I am happy to let you know that Chelsea is in. Eh, umesema leo ni asubuhi na mapema. Alright, 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 Rich. Wacha roho itulie, tuanze darasa. I hope now you're good, you're fine, and we can start the lesson. Eh, alright. Chelsea, say good morning to that young man, tafadhali. He's been taking your attendance. I've had an easy week last week. Ian and Daniel have been helping me. Oh wait. Can you guys see my screen? Perfect, perfect. Thank you. Right, so today let's dive in into identity and access management. Let's see what, when you hear people saying I am, what it means, what you can use this service for, and this is what is expected of you to describe the I am service, list the different types of security credentials that I am supports, and to describe how authentication and authorization is implemented in I am. So fast forward, karibu niseme fast and furious. Anyway, weekend is over. All right, so what is I am and in AWS and how can we use it? So I am is a service in AWS that you use to manage access to AWS services and resources securely. Now, when it comes to AWS, there are services. So these like the IAM, the S3, EC2, Config, CloudTrail, CloudWatch, the services that AWS gives you. And your resources, these are like the servers you provision, your network that you create in your VPC, the users that you have in your IAM, the data you've stored in your S3 and in your databases, the the cron jobs that you have running on systems manager, all this the work that you're doing, the stuff, your personal stuff that is in AWS, in the AWS cloud is your resources. So IAM helps us to control and manage who is having access, number one, to our services, and number two, to our resources. Now, a quick question, and I want you guys to answer me quickly. Answer Nizagidere. This is a question that I told you you'll definitely come and find in your exam. What are the three ways that we use to interact with AWS? You can unmute, you can chat. CLI, SDK, and console. Yes, perfect, perfect. So these are the ways that we can interact with AWS when it comes to um, when we are when we want to interact with AWS. We can use command line interface, we can use SDK, and we can use console. So even those are catered for when it comes to IAM. Now, with IAM, you can create your users, you can create groups, you can create roles, and you're also going to see what are user groups, what are users, what are groups, what are roles, what are policies. These are some of the things that we're actually going to look at today. Now, when it comes to security, we learned that there is authentication and there is authorization. And our Mwalimu Patrick told us that authentication is who is able to enter into our house. Authorization is those who can enter into our house. Are they actually authorized to enter into our bedrooms? Right? So authentication, who can access your resources? Authorization is what resources can a user who has access to your services and resources, what services, what resources can they actually use or provision or create or delete or manage. All right. Now, we have something called an IAM policy, and an IAM policy is an object that, when associated with an identity or a user or resources, it defines their permission. You're actually going to see that an IAM policy is actually a document. At any time you hear of a policy, think of it as a document like this. See, when you're installing a software and you're told to read user agreements, right? And we just say accept and accept or just skip or agreed, right? But not for AWS policy. This document is so important because it's going to say um, resources like for say S3, um, S3, this and this can happen. This is the person with the permission. What about EC2? EC2, user Habakkuk can access EC2. He can create servers. He can manage the servers. Um, uh, he can create what are they called? He can create whatever they are. I can't remember. He can create load balancers, and he cannot say, even the policy can say, Habakkuk as a user of EC2, he cannot terminate instances or he cannot stop instances. So when Habakkuk creates instances and he's using them, managing them, he is limited by the policy to terminate or stop. All right. So the policy is actually a document that says this user has access to these resources and he can do this and this and this and this. So in layman terms, all right. And now I am is a service that helps us to regulate permissions, to regulate users, and it can help us know that who, apart from who can access our services and who can access our accounts, also this person, once they access, what are they supposed to do? If you go to AWS, you're given a root user. Okay, you're given a root user. Now, like when you log in, you see your name say something like joy at restart, something of the sort. So you see your name. So once you create your AWS account, you'll be given a root user, okay, that you can log with. But once you can access your services, The next thing that you're advised to do is create users within AWS. So you can create, for example, like if I was to create an AWS account for Landley for KNI 53 and 54. Higher, I have the restart cohort 30, 53 and 54. When I now I'm now able to access my my console or my AWS account, then I'll go to create users. When I'm creating users, I'm going to say I have user Gideon Kamau at Landley Africa. I have Habakkuk Senelewa. I have Prudence Mwangi. I have Felix. I have Purity and DC. I have Kevin. I have Elias. So these are my users. And then I'm going to specify for my users what can they do. Reason is you want to have eyes on all your resources, all your services. You do not want to have a scenario where everyone has all the access that they can create whatever they want, delete whatever they want, manage whatever they want. You know, a good example is say we create that account and I have my 17 users. And you guys, because I've created you as my users, I've not given you different permissions, so you can do anything you want. I know Salem is going to run to launch EC2 instances kama 15. Someone else is going to run. Rich ataenda afungue S3 na backup screenshots zenye ameongea na Chelsea. Haya, naye huku Musembi ataenda afungue data NoSQL aeke all the screenshots ako nazo za Sandra. Another person is going to run aende aeke, another person is going to run aende afungue containers. Another person, it's going to be helter skelter on our console and on our account, and we really do not want that. Okay, we want to be able to manage our resources. And remember, I know all my students. Nawajua you're my babies. I know all of you. And good morning Musembi. Umenyamaza sana siku ya leo. Right? So, uh, so um, you know that all these resources, they are costly, right? They are expensive. You do not want a scenario where you come and find you have 72 EC2 instances running overnight. You do not want that case scenario because you're going to pay for it through the nose and mouth. All right. So this one helps us to manage access. Okay. I hope now you've gotten a gist of what we are talking about. So let's learn a little bit about the user groups that we have. So this is exactly what we were saying. We have an account user, okay? This is the person who created the account. For example, in our case, if I created the account, I'll be the root user. And me, I have access to all resources. I have privileges to do everything that I want on my console. Then I can go ahead because I know it's a good practice to create you know, to be a good person, create users for the people that you want included, create groups if there are pockets of people and give them their permissions, create roles for services. All right. So in IAM, we can create granulated permissions. We can create secure access for applications. We can have identity federation and integration with other services. I'm going to give you a fun fact for roles. Do you know that for EC2, do you remember the example I was giving you last week where we have our e-commerce site? and it has an EC2 instance, have our server on an EC2 instance, and it needs to collect or store data on our S3. It needs actually to say like collect images from S3. So our website right here uses goes to S3, takes photos, displays them for the users, right? And then the users can see what exactly we are selling. Now, a fun fact is EC2 cannot access S3 without permissions. All right. Any service cannot access another service without permissions. And that is why AWS is so important. So let's learn what is an IAM user. An IAM user is an entity that you create in AWS to represent a person or an application that interacts with AWS resources. And a user in AWS consists of a name and credentials. Now, people, this right here, an IAM user, it represents a person or an application. It's also examinable. It's not just a person, but also an application. For example, if I want to, for example, on my, for you people who have Windows, you want to access, for example, what good example can I have? For example, let's say you have your VS Code. Wow, that's a long route. Let's say you have your Google Drive here on your local machine. Say you're using whoa, what good example can I use? All right, let me just give a vague example. You have an S3 where you used to store all your photos. Okay, instead of going to Google Cloud, using Google Photos, say you go to S3. All right, and S3 is where you're storing all your photos. So anytime you take a photo, you want it backed up on your S3. But then your photo iko kwa your ka Infinix, your ka iPhone, your Nokia if you have a Nokia. Now, for your phone, for your gallery to be able to back up on the S3, it actually needs the permissions. So you can create a user for your gallery, a user for your gallery to be able to back up data on S3. Okay. Now, for a person, for you to be able to access AWS services for a certain client, for a certain route, you can create an IAM user. Okay. A root user is the person who creates the AWS account. He's given the root user. Okay, he's given the root user, and this person has access to all the services, all the resources in the account. This person is the one who can create 178 EC2 instances and delete all of them if he wants. He can use he can use CloudFormation to provision all the resources he wants. He can add people if he feels like and remove them if he feels like. This is the account root user. All right. And we have best practices. Uh-huh. Yes, you can access your account root user by signing in using your email address and password. And also this is very examinable. You can access your root access using your email and password. And remember, for IAM user, you're using your name and credentials. All right. All right. For the root user, you actually sign in with your email, the way you do to Gmail when you're going to sign in into your Gmail or your Google Workspace account. You use your email and password, right? Higher. If you're an IAM user, you're given a name and credentials. And we say that an account root user has full access to all the resources in the account, and no one can control his or her permissions. Yeye ndio anaweza control za wengine. Now, there's a good practice when it comes to AWS. And the best practice is you minimize the use of root credentials. Okay? Let it be used only by the root user when it is totally needed. So, if it's like that, what are you supposed to do? You're supposed to create an IAM user for now the people who do daily operations on your cloud or who need to work on your cloud. Create for them IAM users. All right. Another thing is you can use access keys only when necessary and rotate them regularly. Let's go ahead. You're going to see what are access keys. Then another thing is you enable MFA for all users. So when you guys come to create your accounts, you will be asked whether you want to create you want to enable multi-factor authentication, and it's a good practice for you to enable MFA. Remember, the cloud is in the internet, and the internet, anything can hack. Kama they've hacked KRA on X, who are you? Kama they can hack a whole government, who are we? All right. So it's best practice to have your MFA enabled. Another thing is you can use key pairs only for services that requires them. So use key pairs for when it is totally important. If you really need to SSH into your servers, use your key pairs and you store them securely. Okay. Now, IAM, you use IAM, identity access management, identity, let me see here. I think it's identity and access management, yes. So we use IAM to assign permissions to users following the principle of least privilege. Higher. And we said that, who can tell me the principle of least privilege? Are we giving all permissions to everyone who needs them? Are we giving no permissions at all? Or are we giving just the most important permissions for the work needed? Yes, exactly. Thank you, Musimbi. Very good. Okay. For example, if you require an admin level permissions just for the work needed. Thank you, Elfas, and good morning. Okay, so if we need an admin to have permissions, number one, we create an IAM user and we grant them full access. We use those credentials to interact with AWS. So what you can do, see you've been given your root user, you can now create an admin. Now the admin can have all the full access and he can also be able to create other users as well and give them now specific permissions. Right, now let's go to identity federation. Now, what is identity federation? This is a system of trust between two parties. It authenticates and conveys information needed to authorize access to resources. Now, an identity provider is responsible for user authentication. A service provider, such as a service or an application, controls access to the resources. Later, if you need, you can revoke and modify permissions, and you can delete and modify policies that are associated with an IAM user. Additionally, you can have multiple users that require access to AWS account. You can create credentials for each user and define the access level of access they have to their resources. So identity federation is, think of it as two parties where as a two parties, this identity federation gives you trust between two people, two parties, and it authenticates and authorizes you as a user whether you have access to certain resources. Okay, IDP. And in fact, later in I think later when you're doing your revision, we are going to touch something on federations. We're going to touch on something called like single sign-on. We're going to touch on IDP. For Microsoft servers, they have their own IDP, and we're going to see how they actually work. But for a brief overview, because that is more advanced for CCP. All right, so let's go to security credentials. All right, just a second. All right, so security credentials, types of credentials that we can have. We can have email and password, just like how you log in into Gmail or Google Workspace. We use our email and password, okay? And remember that email and password is used for the root account. Now, once you've created users, and I am user, then you create for them a name and a password. Now, the I am user is going to access the console using the name and password. And then we can have access and secret keys. Hi, these are associated with command line and programmatic requests for the SDKs. Hi, so access keys and secret keys, they are associated with accessing AWS using SDK and CLI. Then we have multi-factor. Tafuteni vumbi, kwanza jua imerudi. Multi-factor authentication, it's used to provide an extra layer of security which you can enable for IAM users and the root user. Key pairs, we use them when we need to access specific services like EC2 through SSH. All right. Now, a simple illustration of what we can have on AWS IAM. In IAM, we can create users. So these are individual entities and also can be applications. So it can be you, Abby, it can be Ivy, it can be Musembi, it can be Chelsea, it can be Rich, it can be Salem, it can be Fan, Misiani, it can be Frank, an IAM user. All right. And then we can have something called groups. Now, groups, remember that here we have a collection of two canines. We have canine 53 and canine 54. So, Patrick and I can create canine 53, a group canine 53, and group canine 54. And we give canine 53 access to their own resources and canine 54 access to their own resources. We give them permissions to do certain things that maybe canine 53 don't have. All right. So that's an example of a group. Then we can have roles. Now, roles are so interesting. Remember, guys, that I told you EC2 cannot access S3 without permissions, right? So what is type of a way that we can give permissions to services? We use IAM roles, okay? So we can give permissions to trusted services entities, like say we can give uh, an IAM role to EC2 instance to be able to access data stored in an S3 bucket. All right, that's a role. And then we have policies, and I told you policies, these are documents. All right, that defines permissions. It defines the allow deny permissions to resources. All right, and a fun fact: policies are in JSON format. In the next few days, you're going to learn the difference between JSON and YAML, but policies are in JSON. All right. So those are the core concepts of IAM. And the benefits of having IAM is that there's centralized control of the centralized access control across AWS. There's granular permissions management. You can be able to say, I want user Abby to be able to only access EC2 instances using Amazon Linux 2 and can only set a maximum of 2 instances bus. So you can set very granulated permissions. And then another thing is you can increase enhanced security. Is someone unmuted? Alright. So you can enhance security without sharing credentials. So you don't have to keep on giving people your root user account. No, you just create for them users. Once they're done with their job, you can revoke their permissions. Another thing is it is scalable for teams, systems, and applications. Remember, I told you like the way we are here, we can have fun. Unataka kumwaga mtama? Tuambie, ulisema nikuje na kikombe ya chai na kiti ya plastic ya white. Tutasikiza tu. Kusikiza hatuwezi kataa. Sawa, fine. All right. So you can use IAM for it's so scalable that you can have different groups, different teams doing different things, and you can be able to control their access from one service. That is IAM. Another thing that we have said about IAM is it can be integrated with other services. It works with nearly all AWS services. And people, I want you to tell me who can take a wild guess. AWS IAM, is it a global use? Is it a global service or a regional service or an easy service? Do we have to set an availability zone for IAM or a region for IAM or is it a global service? Somebody take a wild guess because we will go there, I think, next week, if I'm not wrong. Next week, but one. Yes, Mosembi. IAM is a global service. Yes, Justin. IAM is a global service. It can work anywhere and everywhere. And a good question that can come in your exam will ask, um, Landly Africa, our organization here, has 15 users, all right? Joy is traveling to Seychelles. Everybody say amen. Mseme amen na nguvu tafadhali. Tusikosane.
Amen.
Amen. Amen.
All right. So Joy is traveling to Seychelles, all right? And Joy needs to work. Hata kama anaenda Seychelles, she has to work. So how can Joy work if she's going to another region? Ina manifest vibaya sana. I hope Esther anasikiza. Esther, I hope you're with us. I hope you can hear our prayers. All right?
Yes, yes, yes.
All right. So you'll be asked, Joy is going to Seychelles and she needs to work. And I have been created for a user in our account Landly Africa, but I'm going to another region. How will I access the company resources on the cloud? And the simple answer is I'll just do my work normally because IAM is a global service. It does not rely on a region, it does not rely on an availability zone. It is everywhere, it is a global region. And some of the global services that you saw were actually some of the reasons why a few weeks ago we had an issue with AWS. Grim Reaper visited AWS US East 1, and most services that are global actually run on US East 1, right? So yes, AWS is IAM is a global service. All right, so we've learned that we can integrate IAM with other services. It works seamlessly across almost all services. Another thing we've said, we have identity federation, where it enables users from external identity providers, like now the one I was telling you for Microsoft. I've just forgotten its name. It allows access, and it enables users from external IDPs, like corporate directories, social providers, to access AWS resources without creating separate users. A good example by the way of an IDP I've just remembered, when you guys are logging in, say to a website, say you want to access a certain website, for example, what can I say? For example, if it's Upwork, I don't know, Upwork, so you just need your email. All right, say like for example, you want to sign up for, all right, maybe let me just give a wild guess. Maybe you want to sign up for Medium, and instead of creating, remember the way Kitambo, if you wanted to create accounts, you'd have to input your email, joy Naro at landlyafrica.com, and then I have a password there, ta da 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 da, and my funny symbols. And next time, if I want to sign in, I'll then have to sign in again with my email, joy Naro at landlyafrica. You see? But nowadays, yes, Musembi, we just use sign up using Google, sign up using GitHub, sign up using Facebook for those who are old like me. You get? And this, it has made it so easy for us to access a lot more resources easily, even to sign in. You do not have to keep on struggling. Like I know of certain e-commerce sites, you do not even to have a password. You just have your email and they automatically send you a one-time pin, and you do your shopping. Because they are, most people actually hate having to enter 15 passwords. They cannot remember tomorrow their password, they re-enter again, so it's good. Another thing that we can have is secure access to applications. So we said we do not want, for example, EC2 has to have enough permissions for it to be able to access S3 or any other service. And another advantage you said is granulated permissions, where you can set very fine grained control over who can access what. All right. Now, with my long shot, guys, tell me. Let me just hide this here. Yes, answer Zakidere. As a root user, what do you use to sign into your IAM? A root user uses what to sign into their console?
Email and password.
Very nice, Alphas. Very nice. Aya. An IAM user uses what to sign in into their console? Guys, okay, I've repeated that like 15 times.
Username.
Yes, username and credentials. Don't forget credentials, all right? Higher. Now, we said there's also access keys. Access keys is not credentials ni username pia. So Musembi, yes, kuna username, kuna name na kuna credentials. For users, I am user, kuna name plus credentials. Okay, when you guys go ahead onto the lab and you create your IAM user, when you're logging in like that user, you're actually going to see the difference between signing in as a root and as a user. Okay, kwanza user lazima upeane jina. Okay, lazima upeane ile jina umecreatiwa. So guys, access keys, tulisema access keys ni za somebody, access keys.
Accessing the EC2.
Hizo ni key pairs. Kumbuka mlikuwa mnatengeneza labs user key pair, labs user.pem. Key pair ni kama EC2 ku-SSH. Very good Sandra and the rest. Yes. Access keys ni za SDK na CLI. Very nice. Sawa Clinton. Key pair ndio ya EC2.
Okay,
Alright.
okay.
Very nice. Sawa. All right, let's go to IAM authorization. So authorization, you allow users to access AWS services by granting them authorization. You assign permissions by creating an IAM policy. Permissions determine which resources and operations we are allowed to. So in short, authorization in AWS, IAM, it determines what actions a user, a group, or a role can perform and which resources they can access. It follows strict permissions model. Remember the ones that we've said, the principle of least privilege, right? It uses the principle of least privilege to ensure secure and controlled access. So authorization basically says user this one, group this one, role this one, you can do this. User this one, you cannot do this. Group this one, you cannot do this, but you can do this. Okay. Now, what are the key characteristics of authorization? Authorization, it contains explicit authorization. It says users must be granted permissions via IAM policies to access IAM services. It's very clear, okay? And it is policy based. Permissions are assigned by creating and attaching an IAM policy to users, groups, and roles. And you guys, I said a policy is in which format? It's what type of a document is a policy? IAM policy. What type of format? I'm a programming language. Do I even call it a programming language? Yes, it's a JSON. It's a JSON document that guys, if you hear gunshots, kindly ignore. All right, a JSON document that describes what permissions, and it is attached to users, roles, and groups, specifying the permissions assigned, all right, to the person, to the user, to the group, or to the role. About authorization, there are no default permissions. You, as the root, you have to specify them, okay? Or even as the admin, you have to allow or deny. Hakunanga permission inakuanga allowed 100%. All actions are denied by default, okay? For permissions, for the policy, all permissions are denied. Nothing is allowed. For example, like if I create a user Clinton right now and nimpe access aingie kwa account yangu, hakuna kitu anaweza fanya because I've not given him any permission whatsoever. But then because it comes by default, it comes as denied. all permissions are denied, unless now I go and allow for maybe creating EC2, storing in S3, something of the sort. And we said IAM is global. It is not region specific, it is not availability zone specific. It's a regional service. Okay. All right. I hope umeshika. Now, let's go to MFA. Multi-factor authentication is that where users can know their permissions. Let me see this. Without the admin telling them. Yeah, you'll know your permissions very well. You'll know what you cannot create. That's how you're going to know your permissions. Actually, the things that you cannot do, you won't be able to do. For example, if you wanted, like, was it Salem who was saying that, or Ridge, either of you, you are saying that you are trying to do something on a certain lab, but you're not able to. And we said that each lab has its own permissions, right? So whatever you cannot do, you cannot access. All right. So what is MFA? MFA is multi-factor authentication. Like, is there a command that shows permissions? I think that's a very good question. I'm not so sure about that. That's something, by the way, we can look up. Anyone, somebody look it up for me. As we proceed, MFA is multi-factor authentication. It provides an extra layer of security by requiring users to present a second form of authentication. Now, we said that in IAM, it allows you to authenticate users, authorize users, and then for authorization, you can specifically allow or deny access to resources. So MFA, it enables for a second form of authentication. How does MFA work? So initial authentication is you provide your account ID, your IAM user, and password. So remember, was it Musembi? Musembi was telling you that you require your name and credentials. Your name, you have to be given a name. Thank you so much, Daniel, for that. But then we should try this out when we are in the lab. All right. So the very first form of authentication is number one, provide your name, that's account ID, provide your username and password. Now, for the MFA, it's the second stage. So after your password verification, AWS prompts you for a unique MFA code. This code is generated by a linked MFA device. For example, for example, in my account, I use Google Authenticator. All right, like that's a smartphone app. Yes. You can use Authenticator, or you can use a hardware token. Alternatively, if you're in the countries where AWS sends messages, you can receive an SMS, and they also send emails. Now, once you've been authenticated, then you can log in successfully. Your access is granted. Um, You can access AWS resources by using the following. We talked about them. We said it's console, CLI, and SDK. And in SDK, where we can and APIs for various supported environments, rather programming languages. For increased security, AWS recommends you to enable MFA with your users and systems so that you can ensure security, so that your users can be authenticated very well before they can have access to your resources. And we can have a few compliant MFA compliant applications that we use. We have Google Authenticator, we have Authy, we can use SMS, and we also said we can use email. You can also use AWS Security Token Service. So this is a very interesting service. It's called AWS STS. What AWS STS does, I want you guys to remember this, and it's good that you write it down. What you just need for your exam. AWS Security Token Service STS. It's for giving you something like a one-time PIN OTP. All right? STS is for giving you a one-time PIN. It's for a request temporarily credentials. Okay? Ni kama ya kukupea OTP. Remember that. So you can use STS to supplement MFA. Hope you guys have understood. IAM implementation. Let's go to IAM users. All right, who is an IAM user? An IAM user is an identity that you create within your account to represent a person or an application that interacts with your AWS services. So, number one, you create it manually. So you can create it from your root user, or the admin can create, okay? For example, like here, we can see that for our access, we have the root user, and the root user is able to create an admin. And then now this admin can create John, can create mother, can create a developer. All right. So a user is an entity that you create manually to be able to access a person or an application, to be able to access your resources. And it enables the user to access AWS via the console, the CLI, or the SDK, or even APIs. So when you create users, you can give them access to either your console, they can access it using your AWS using their console or their CLI or SDK. For example, if you have a developer developing for you, you can give them access to the console and SDKs or APIs. If you have a HR, you can give her access using to use the console only. All right. And number third point to note is there are no default credentials. Credentials, that's the password, access keys, username. You have to create them, explicitly create and assign them to the user. And there's flexible representation where you can present as individuals or as applications. For example, like this here is an application, dev application one is a user created by the admin. We can have Joan and Martha. Now we have a best practice. Create a separate IAM user account with administrative permissions instead of using the root user. All right, this we said it earlier. Let's go to IAM groups. Haya, IAM groups is a collection of IAM users that share common permissions. For example, in our case, I said we have Kenai 53 and Kenai 54, right? Kenai 53 has a group, as a group, have their own permissions, they have their own groups, right? And under Kenai 53, we have actually 5 groups, right? I don't know if you guys had any folded. Under Kenai 54, we have 4 groups. So each group has a set of its own permissions, all right? So you can create a group for the users who share common permissions, and groups they simplify the access management by allowing you to assign policies to multiple users at a time. For example, in an organization, if let's say we have developer Clinton, developer Habakkuk, developer Mosembi, they are developers. We can group them as group devs. And then maybe we have DevOps, we have Rich, we have Patrick, we have Salem. Well, we're going to group them as DevOps. So these ones will be in charge of deployment. But whatever developers, you'll be in charge of servers and creating applications and all that, and then you give the DevOps people your applications to deploy them for you. Maybe then we have Akina Joy, Kina HR, finance, all these other people you can be grouped into, say like HR, maybe HR kuna HR1, HR2, people's, what do they call them? People's management or people's person or people's someone, people's success people, those people for HR, they can be grouped into one group, right? And given permissions as a group. Instead of now having to create user Clinton, nimpe all permissions as a developer. And then I go to user Musimbi, pia yeye nimpe the same kama as a Clinton. And then we go to user maybe Frank as a developer, I give him the same permissions as Clinton. So instead of doing all these repetitive work, you can group Clinton, Musimbi, and Frank under a group called devs and give them one set of permission. All right. So what happens is the key features is that number one, user collections. It groups IAM users. IAM users, but there it does not group applications, just IAM users. And it uses IAM users who have same interests, rather same permissions. There are no default groups. You have to create them. All right, explicitly, manually create them. And then this is a question I've seen in the exam, and I am pretty sure I failed the day I did my exam. Groups cannot contain other groups. All right. There cannot be nesting in groups. Guys, I need you to note these things down that I'm saying, because we might not be able to come back to them after tumepita hapa. Groups cannot be nested. A group cannot be under another group. All right. A group cannot be under another group. There is no nesting in groups. All right. But a user can belong to multiple groups. For example, you can have a user in the developers group, and also the same person appears in the DevOps groups. A user can appear in multiple groups, but groups cannot appear in other groups. Yes, Musembi, groups cannot groups zenyewe, not users, groups cannot belong to other groups. They are individual entities, okay? But users can belong to multiple groups. If you've understood that, kindly give me a thumbs up. Perfect, perfect. Very nice. Perfect, perfect, perfect. All right. Asante Musembi kwa makofi ya mwisho. Let's move to roles. Now, what are roles? An IAM role is an identity with permissions that can be temporarily assumed by trusted entities to access AWS resources. Now, the thing about roles, it's temporary access. Okay? Remember that if you're writing somewhere, write a role dash temporary access, give temporary access to AWS resources. And you can give a role to a user, to someone. For example, I want to build a Shopify store and I want to subcontract Ridge to come and build it for me. And he'll be done by next week, Friday. After next week, Friday, Ridge won't belong to my group anymore. So what can I do? I'll create a role for Ridge, giving him temporary access to my Shopify store. And after he's done creating my Shopify store, I revoke the access. Another example is I want to give my Shopify store access to my S3 so that it can pull up images. Of course, kitakuramba vizuri sana. I want to give access to my Shopify store to access S3. Only when it is accessing S3, that's when it can be able to, and maybe I just want my Shopify store to only access images in a certain bucket written Shopify images only. All right. So what will I do? I'll create a role and then I'm going to go to my EC2. I'm going to let EC2 assume this role. The uh, excuse me. Yeah. Polene, excuse me. Now, EC2 is going to assume this role and then it can be able to access my S3. All right. So, number one, roles allow users or applications or even other services to access resources securely. When a role is assumed, AWS uses temporary security credentials. Permissions are defined using IAM policies and attached to the role. All right. So we're going to go to our policy. Remember, we said policy is a JSON format document that explicitly shows whether you're allowing or denying access to services. Okay. So I'm going to go create a policy, IAM policy for EC2 S3. I'm going to say EC2 instance can access S3 bucket. This one for taking images only, not even for storing anything. All right. Do not store. So he could have maybe when it comes to maybe storing data, it's deny. Accessing data from this bucket, it's allow. All right. So I'm then going to take this IAM policy and I'm going to attach it to the IAM role that I'm creating for my EC2 instance. And then now my EC2 instance, then I'm going to be given temporary security credentials that now the role is used to access the S3 bucket. All right. A use case. A use case for using roles is with federated users. A federated user does not have a permanent identity in AWS account the way an IAM user does. To assign permissions to a federated user, you can create a role. For example, we said a federated user is we people who are using sign in with Google, sign in with Facebook, sign in with GitHub, sign in with Microsoft. We are the federated users. So for you to be able to have access to whatever resources I want you to have, we are going to assign a role and patch it to your user federated user. For example, in this diagram, a role is temporarily given to a user and an application. The purpose of this temporary role is to access the storage of Amazon S3. So we've gone through this, how to create an IAM role, and we said we create a policy. Now, when we create a policy that specifies what this role is supposed to do, then the policy it specifies it specifies who is allowed to assume the role. So, for example, we can say EC2 or the trusted entity or principal. The access or permission policy defines which actions the resources the principal is allowed to access. So the access or the permissions is going to say EC2 can access S3 and they can pick images from this bucket. All right, the principal can be any of the following. It can be an AWS account. So in the next few lessons, you're going to learn that you can have multiple AWS accounts and you can bring them together. So if you have multiple AWS accounts and you want account, maybe you have account A and account B. You want account B to be able to access an S3 bucket in account A. You give it a role. All right. So it can be an account, it can be a service like EC2, it can be a person, it can be people who are logging in using IDP, something of the sort. And when it comes to accounts, if you're going to do solutions architect, that's one of the places where you need, like, you can get 15 or 20 questions from that, from just from security in accounts, in different AWS accounts. I don't know if Mwalimu Patrick aliteseka kama mimi when doing solutions architect. I think it's one of the hardest paper I've ever sat for. Then let's go to permissions. Onyo kwa onyo, we are almost done, my people. Do not fret, do not worry. Thee thou servant is we are almost like 10 pages away. So what are IAM permissions? Higher. And IAM uses policy-based evaluation logic to determine whether a user, a group, or a role is allowed to perform a certain action. For example, it will ask itself, is there an explicit deny? If there is, deny completely. Is there an explicit deny? No, there is no. Then allow. Is there an explicit allow? If yes, then allow. Is there an explicit allow? No, then explicitly deny. All right. So it uses logic to determine whether a user, a group, or a role is allowed to perform a certain task or access a certain resource. For example, let's say EC2 with accessing S3. So let's say we have not given EC2 access to S3. So is there a deny explicitly? Is EC2 denied explicitly? Yes. So it's going to be denied. But if I had not denied explicitly and I said deny, maybe yes, maybe no, then we're going to come here. It's going to ask itself, is EC2 explicitly allowed? And it's going to check if I've allowed EC2 to access S3, it will be allowed to access S3. If not, then it's going to be implicitly denied. Access denied. So even though that's what it will be told. Do you remember, guys, when we were learning? I don't know if you guys did digital logics back in the day, where we had logic operations. Yes, the logic gates. If no, if no plus no equals no. No plus yes could lead to a yes. Yes plus yes leads to a yes. Yes plus no leads to an implicit no. So on the high overview, that's what it means. All right. So using policies, you can fine tune the permissions that you're granting to a user, a group, or a role. And we've said that it uses JSON format. You can use them with version control system. You can actually use them. Yes, you can actually use them with the version control system. And it's best practice to define the principle of least privilege when you're assigning permissions to a group, a role, or a user. All right, so it's just explaining what we have. Let's go to IAM policies. So IAM policies, they are written in JSON format. I'm repeating because you might also find it in exam. All the way to DevOps, by the way. If you'll do a DOP, you might find it there. So it can be version control for audit tracking and change tracking. What you do, you define the actions, you define the resources, and you define the conditions. For example, you can say S3 put object, and the resources give specific S3 bucket. For example, bucket Shopify images. All right, those are the resources. And the condition, IP address, time of day, such things. What are some of the best practices when it comes to IAM policy? Number one, apply the principle of least privilege. Use explicit deny to block sensitive actions or override broad permissions. Regularly audit your policies. So remember venye Musembi has said that if you forget to revoke a role, kitakuramba. So it's very important that when you're giving policies, when you're attaching policies, at least um, audit your policies once in a while, once in a week, twice in a week, so to check whether they are compliant. And you attach policies to users, groups, or roles based on access needs. Aye. So you can attach policies to the users, the groups, or the roles, or even resources. And you can have multiple attachments. A single policy can be attached to multiple entities. For example, you can have, if for example you have 5 EC2 instances, you can attach them to the same policy that grants. For example, I have 5 EC2 instances running my Shopify store. I can use I can attach the policies to the 5 EC2 instances to my 1 S3 bucket. So a single policy can be attached to multiple entities. And then remember we said that evaluation of permissions is done logically, just like we explained earlier. And use explicit deny to override any allow. For example, if maybe we say that I create a policy that says Naboth can access Sandra, where Naboth can text Sandra. Naboth is allowed to text Sandra. And then I say, maybe I give an explicit deny. I say, Musembi has an explicit deny to text Sandra. Well, Naboth can access a message, can send a message to Sandra, but because I explicitly denied Musembi from texting Sandra, Musembi atajua irudi. Sitaki kuletwa juu na rage. Musembi will just call. Very nice. All right. So because I do not want Musembi to text Sandra, I'll say explicitly deny, and it will win. There are no default permissions. Remember, guys, I told you when it comes to policies, all actions are denied by default. You see, you guys, you've made Frank to laugh. Eh? Kijana wa watu kwao ni saa moja na kwenye jua imewaka. All right, there are different types of policies. We have identity-based policies. These are attached to IAM identities, like the IAM users, groups, and roles to control access. They are managed policies, they stand alone policies, and they are reusable across multiple identities. They have um, identity-based policies. These are permission policies that you can attach to a principal or an identity, such as a group, a role, or a user. The policies control which actions the identity can perform on which resources. So this is like what we've been talking about. And they are categorized into two. We have managed policies and we have inline policies. Managed policies, they are standalone policies that can be used across multiple identities. Like they can be used across multiple users, multiple groups, multiple roles. And then we have inline policies. Inline policies, these are policies that you create and manage, and they are embedded directly into a single role or a group. So, for example, like if we create a group and we can create a policy for that particular group and attach it to that group or role. They are embedded directly into a user group or a role. And then we have resource-based policies. And resource-based policies are attached directly to AWS resources. For example, like what you were saying on S3, to control access by specified principals. They are always in line, no managed version, and they define who can access the resources and under what conditions. For example, you can say, uh, for example, a good example is like, we have said that resource base is attached, for example, to AWS resources, for example, like an S3, and it's going to say, this policy is going to say, only EC2 instances can access this particular S3 bucket. All right. Best practices for policies: use groups to manage shared permissions efficiently, apply the principle of least privilege to grant permissions only when needed and the only permissions needed. Use managed policies for consistency and reusability. We've said that managed policies can be attached to multiple users, groups, you know, and test the policies using the IAM Policy Simulator. So you have a service called IAM Policy Simulator where you can test your policies. By the way, it's very, very important. There's this time that I was creating a particular IoT device for an organization, and this IoT device, it was, what was it sending to the S3? It was sending I think it was sending, was it to the S3? No, actually, the IoT device that I was creating was mine. It was the one that was telling you guys for Nami. So my server was in an EC2 instance, and I was storing the messages in an S3 bucket, and I had a Lambda function that needed access to the S3. So I had to specify a policy for the Lambda function for it to be able to access the data. Remember that a message is being sent, so like your location, your name, your device ID is being sent to the S3. So this Lambda function, for it to send now the message or email, it needs to collect this message from S3. So I had to give the Lambda function, as I needed to create a policy and attach it to the Lambda function that enabled it to access an S3. But I had a lot of issues, like it's like trial and error, because you don't know whether it's going to work, whether this message is going to be crafted nicely by the Lambda function. So when you use an IAM policy simulator, it can tell you exactly this Lambda function. It can access the bucket, but the format which is accessing the data is wrong, or it might not be able to pick up all the data, or it might not be able to read the data as you need it. All right, so you can use an IAM policy simulator to test your policies, and also use resource-based policies to restrict access based on conditions like IP range and external identity. So those are the best practices when it comes to IAM policies. Let's see, we have an example here of an IAM policy. All right, so here we have the version number of the IAM policy. So it was created on this date, and its effect is to allow DynamoDB and S3 the resources DynamoDB, so it can get the region, the account number, with authorization. It can get the table name, right? This is the resource needed. So from DynamoDB, we need the table name. From the S3, we need the bucket name. Okay. Now, this means that there's an explicit allow given to users access to specific DynamoDB table and a specific S3 bucket. And then we also have on the policy, we have an explicit deny that says action is on the DynamoDB and S3, not resource. So they cannot access the resources within this table, and they cannot access the resources within this bucket name. So this is an explicit deny that ensures the users cannot access the resources within the DynamoDB table and within the S3 bucket. An explicit deny takes precedence over over an allow. So you see, the very first time users had been given access to the table and to the DynamoDB table, and they were also given access to this S3 bucket. But then after it, there's an explicit deny, and it's saying not resource. So you cannot access the resources on this table and on this bucket. And the reason why this policy will deny the user from accessing the DynamoDB table and S3 is because they deny it takes precedence. Now, if you are going to sit for solutions architect after cloud practitioner, if you're going to certify for SAA, you must be able to read IAM policies. You must be able to explain them into details. And that's why, guys, when you are starting EC2, I told you one of the superpowers that you can have is to read code. Okay? You're going to need that, whether you're going to do SAA, developer, associate, DevOps, you're going to need to read code. All right. So that's what the policy is saying. IAM policy assignment. So an IAM policy, we said that it defines the permission attached to multiple IAM entities, so like the users, the groups, and the roles, the group, the role, and the user. So these are documents. Remember, guys, we said these are document, and it shows what a user, a role, or a group is allowed to do or is denied to do. Okay, you can assign the same policy to multiple users, to multiple groups, to multiple roles, and this ensures that your policy is reusable. All right, people. So let's see, let's go to our lab. Let's take a 30 minutes break, come back at 11. Guys, I'd like to know who's going to lead us in the lab. Who would want to lead us in the lab? We do for you the lab. People, anyone who'd want us to do his lab? Who has their machine with them? We are going to do lab 279. We are going to see the different parts of IAM. We're going to create IAM users, IAM roles, IAM policies. We're going to see how a policy looks like. We are going to allow or deny a few permissions here and there. So who's willing? Patrick, you can stop recording. Thank you so much. So who's going? Yeah, people. No one. You go do the labs by yourself.